Hello, this video will be explained about the mechanism of free radical substitution of alkane. Free radical substitution is a type of reaction. The name of the reaction is halogenation of the alkane. So in this case, I use a simple alkane which is methane. When we say halogenation, we react with the halogen. So it can be Cl2, Br2, F2 or I2. In this case, I take Cl2. In the presence of inert solvent, which is CH2Cl2, with the presence of UV or light or heat to produce a product. So in this case, when we say alkane, there occur halogenation of the alkane, there will occur free radical substitution. What will be occur is 1H from the alkane will be substituted with the halogen. So 1H from the CH4 will be substituted with the halogen Cl to form CH3Cl. So in our syllabus, we only focus on the mechanism of mono substitution. So means that we only focus on the substitution of one hydrogen of the alkane with the halogen. So in this case, CH4, we substitute 1H with the halogen, becomes CH3Cl. So mechanism of the halogenation of alkane, doesn't matter what alkane, they will involve 3 steps. Chain-initiating step, chain-propagating step, chain-terminating step. So this step must follow the order. So they must follow chain-initiating step, then chain-propagating step, then chain-terminating step. Okay, so in this video, I will explain one by one. So first, chain-initiating step. So in chain-initiating step, we will break. Because we want to substitute H with the Cl, so we will break the bond between Cl2. So chain-initiating step only involve the halogen Cl2. So chain-initiating step involve the fragmentation of the halogen molecule, in this case chlorine molecule, by using the heat or light, the condition that we use. Okay, so if we want to show mechanism, we want to show how the bond is breaking, how the bond is formed. So we cannot write Cl2. What must show the bond between Cl, because we want to show how the bond between Cl is breaking to substitute Cl, one Cl to the alkane. Okay, so this Cl bond, as we know that they are non-polar bonds, so they will occur homolytic cleavage. So they use a UV as a condition. They will occur homolytic cleavage. So both electron or 2 electrons from the Cl bond will break symmetrically. So 1 electron will goes to the Cl on the left hand side and 1 electron will goes to the Cl on the right hand side. So we use a single-headed arrow because we show the movement of 1 electron. So what happens to the product? We will produce Cl with unpaired electron. Because we gain 1 electron, so we produce 2 Cl with unpaired electron. So we call this one Cl free radical, chlorine free radical. Okay. So this step produce 2 highly reactive chlorine atom or chlorine free radical. So you must know that free radical is very reactive. So when they are very reactive, they will initiate another reaction. They will initiate the another reaction, which is they will initiate the step number 2, which is chain-propagating step. Okay, I repeat back. This one is the equation of the reaction. So in step number 1, we already occur the bond breaking between Cl in the Cl2. So we produce Cl free radical. Like before, we produce Cl free radical. So not all Cl2 already become Cl free radical. We have in one beaker, of course, we have many Cl2. Maybe during the step number 1, only half of the Cl2 is breaking, or only quarter of the Cl2 is breaking, or only one Cl2 is breaking. So we produce Cl free radical. So Cl free radical, when we say free radical, they are very reactive. So they will initiate the propagating step, which is they will react with the CH4. So remember, our reactant only 2. When we produce Cl free radical, they will react with the CH4. What they will react is to occur bond breaking between CH to substitute H with the Cl. So in chain propagating step, because we want to show how the CH bond is breaking, how the H will be substituted with the Cl, so we must show the bond between CH. If we want to show all the bond, means that you want to draw expanded structure of the CH4 also can, but sometimes we only show the bond that will occur bond breaking. So CH bond will occur bond breaking. So we show the bond. So we react with the free radical Cl that we produce in step number 1. So as we know that Cl free radical only have one electron. If we want to form a bond, they need one electron because one bond is 2 electron. So Cl already have one electron to form a bond. So they need another one electron to form bond. So where they will get the electron to form a bond is from the CH bond because we want to break the CH bond. So this CH bond, as same like Cl2, is a non-polar bond. So in alkane, they only have CC single bond and CH single bond. So CC single bond and CH single bond is a non-polar bond. So they will occur homolytic cleavage. So what happened in here? They want to form a bond with the Cl. So one electron from the CH bond is combined with the Cl free radical. So they combine. So the arrow must show how they combine. This electron from the Cl free radical combined with one electron from the H. So you remember, use a single-headed arrow because moment of one electron. So it means that these electrons are meet together to form a bond. And then another one electron from this bond is breaking. It goes to C. So what product you will produce is HCl. So this HCl is get from one electron from this CH bond and one electron from the Cl free radical. So they already meet. So they will form a bond. And then we produce CH3 free radical. Okay. As we know that free radical, so this step produce a hydrogen chloride and methyl radical. CH3 free radical. So as we know that free radical is very reactive. Okay, back to our equation. So in step number 1, we produce Cl free radical. As I mentioned before this, not all Cl2 already broken in chain initiating step. Maybe only half, maybe only quarter of the Cl2, or maybe only one Cl2 already broken to form Cl free radical. So in the chain propagating step, they initiate the reaction by reacting with the CH4. And then produce CH3 free radical. So when we produce CH3 free radical, as we know that free radical is very reactive, they will initiate another reaction in the same chain propagating step. So it means that chain propagating step, we have two equations. So the CH3 free radical will initiate the reaction by reacting with another Cl2 that doesn't broken yet. So in step number 2, chain propagating step, the second equation is CH3 free radical that we produce in equation number 1. In chain propagating step, we react with the Cl2 that doesn't broken yet. So what will occur? CH3 free radical, when they are free radical, of course they want to form a bond. So they already have one electron to form a bond. So they will combine with another electron from the Cl free radical, Cl2. Okay, so one electron from this bond is one electron from the Cl bond will go to the combine with the CH3. So they will occur homolytic cleavage. So remember Cl2 is non-polar bond, so they will occur homolytic cleavage. So one electron will goes to CH3 to combine with CH3. So they will combine. So these two electrons is meet. One electron from the CH3 free radical, one electron from the Cl free radical. And then the one electron here will goes to another Cl. So what product we will produce is CH3Cl. CH3Cl molecule and also Cl free radical. As we know that if we produce Cl free radical, free radical is very reactive. So they will initiate another reaction in chain propagating step, which is they react with another CH4 that doesn't react yet. Okay, so it means that they will produce this equation back. Cl free radical react with another CH4. So means that these two chain propagating step, this first equation and the second equation are repeat in step number 2 in chain propagating step. Okay, so that one is chain propagating step. So means these two reactions that occur in chain propagating step are repeat until they produce a product, until they produce a lot of product. Okay, so because this chain propagating step is keep repeating, we need to have chain terminating step. Chain terminating step to stop the reaction. So this step cause the chain to terminate by use one or both of the reacting intermediate. Okay, so as we know that in step number 1 and step number 2, we have produced two types of free radical. We produce Cl free radical and CH3 free radical. So back to the equation, in step number 1, chain initiating step, we produce Cl free radical. In step number 2, we produce CH3 free radical and Cl2 free radical. So means that we have two types of free radical, Cl free radical and CH3 free radical. So if we have two types of free radical that produce, means that we have three possibility of chain terminating step, which is Cl free radical meet together to form Cl2, or CH3 free radical meet together to produce CH3, or CH3 and free radical and Cl free radical meet together to form CH3Cl. So chain terminating step means that free radical meet free radical, because we doesn't want to produce free radical anymore, because terminating means that we want to stop the reaction. So free radical must meet with free radical also to produce a molecule without any free radical to produce anymore. Okay, so Cl free radical meet with the Cl free radical, one electron meet one electron, so they will form a one bond. So we not form another free radical. So they will terminate the reaction. So the reaction will not continue again. Okay, that one is chain terminating step. So what we can conclude that step number 1 have one equation. Step number 2 have chain propagating step, have two equation. Step number 3, chain terminating step, have 3 equation. Okay, they must have all these 6 equations. Chain initiating step, 1 equation. Breaking of the halogen molecule, chain propagating step involve 2 equation to produce another free radical, and then chain terminating step, they have 3 equation because they have 3 possibility to stop the reaction between Cl free radical meet together, or CH3 free radical meet together, or CH3 free radical and Cl free radical meet together. Okay, so as an example, you can use this exercise, which is reaction of propane with the chlorine gas in the presence of ultraviolet light to form two monochlorinated product. Okay, so I show the A, the right reaction equation. So let's say propane means that we have 3 carbon. So this one is a propane. When they react with the halogen, which is in this case, they say chlorine, Cl2, in the inert solvent CH2Cl2 with the presence of UV. Okay, in this case, we have a lot of H. Okay, and the first carbon, we have 3 H. So we can say that the first carbon is primary carbon. The second carbon is secondary carbon. The third carbon is tertiary carbon. Primary carbon, sorry, there is also primary carbon. So in this case, we can produce 2 products. So the primary carbon, if we substitute H with the Cl, we will produce this product. So this one is 1 chloropropane. I also can substitute the secondary hydrogen with the Cl. So I will produce 2 chloropropane. So this one, we will produce 2 type of product. So if we have 2 type of product, so one product will become major product. Okay, so which one is a major product? If the Cl is bonded to the more stable free radical. So as we know that before we react with the Cl, C is a free radical. So this one is a major product. This one is a minor product. Because why they are major product? Because the Cl is attached to the secondary free radical. This Cl is attached to the primary free radical. So as we know that secondary free radical carbon is more stable than primary free radical carbon. So they are major products. So you can try, do the mechanism, do the reaction mechanism. Question number B, write the reaction mechanism for the formation of the major product. So only focus about the formation of the major product. Okay, so do the chain initiating step, chain propagating step, chain terminating step for the formation of the from the propane to produce a major product. Good luck. See you on the next video.